There's one thing we haven't talked about so far in any detail, and that's memory. Well, that's really because in JavaScript, we don't have to talk about it. We create our variables and our objects, we use them, and we forget about them. But this isn't always the case. In several languages, you can't just create an object, use it, and forget about it. You have to manage the memory that that object uses, manage the lifetime of that object. If I was to show you some pseudocode examples, it would be that instead of just creating an object, we first have to manually allocate an area of memory. We have to grab hold of a piece of RAM and say, I'm going to use this. Then we can create our object and we can point it to that area of memory. We say, that's what you're using. That's where your data is being stored. We use that reference, what's called a pointer, to that object and just use the object, call its methods, access its properties. But at some point, what we're going to have to do is realize that we're not using it anymore. We don't need that memory, so we free the memory. Doesn't sound too hard, but when you start passing around these objects, you start calling functions, you start having a long-lived program, this can get quite difficult. A very common mistake is this. We allocate some memory. We then create an object. We start using that object, and then nothing. We actually don't need the object anymore, but we forgot to free the memory. Or we thought we were freeing it, but we didn't free it properly. Well, that gives us a memory leak. Not a problem if you only do this once, but if you have a long-lived program that creates thousands of objects, as our program runs, it's going to get slower and slower and take up more and more memory, and at some point may even crash because of it. But a memory leak isn't the only problem we can have. If, for example, we go back to our first object where we've already freed up that memory, well, there might still be a variable that's actually pointing to that area of memory. It's what's called a pointer. And if we try and use that variable because we think the object still exists, but it doesn't, we have what's called a dangling pointer, and that can actually cause our program to crash. And because memory management is difficult code to write, what's happened is as more high-level languages have evolved, there's been different methods for dealing with it. If you remember early on in the course, we talked about the idea of low-level to high-level languages. That languages like assembly language and C were actually quite close to the machine code. You had to know a lot about how the machine operated. Whereas things like Java, C#, and VB.NET were further away. You didn't have to think about that as much. Well, memory management is one of those areas. If you're working with assembly language and C, you have to do a lot of manual work to allocate and free areas of memory that you're using. As you start to get into the more modern high-level languages, there are techniques for dealing with it. Objective-C and C++ can choose to use something called reference counting. This is preferable to manual memory management. It allows us to keep a counter of who's using the object. But rather than manually free the memory, we just allow the system to free it up when it realizes that counter has reached 0. If we move into languages like Java, C#, and VB.NET, there's a memory management technique called garbage collection. Rather than keep track of individual objects, what happens is the system itself keeps track of how much memory your application is using. And at certain times in your program's lifetime, what it's going to do is scan through all your objects and figure out which ones are still relevant, which ones are still being used. So it might take a sweep through 1,000 objects, clear up 500 of them, and leave 500 of them around. It's called garbage collection because it batches this up. It doesn't happen all the time. In fact, you can't even guarantee when it will happen. And when you're dealing with these languages, sometimes as a programmer, you can kind of suggest to the garbage collector that it might be a good time to go and clear up areas of memory. But you don't have to work on the individual level of the individual objects. And further up, when you get into more scripting languages, it's really fully automatic. You have either no or next to no control over when memory will be reclaimed. Now you might think, well, the automatic ones sound great. The issue is, of course, that the more automatic it is, usually the slower it is, the less efficient it is. Because while writing manual memory management code is tedious, it's difficult to do, if you can do it right, it leads to the most efficient use of memory. And if that's your goal, then you might be looking at languages that allow you to do manual memory management. However, for productivity, and particularly because we're in a world where we really don't have to worry about memory quite as much as we used to going back a couple of decades, you'll find that the higher level languages using things like garbage collection, they usually win for being able to create code and create programs faster.